Hi, this is the walkthrough for the AQA Trilogy Physics Specimen 1 Higher Set 1, Question 1. The question gives you an electric circuit. Important to note straight away that it tells you the lamps in this circuit are arranged in parallel and they are identical, and the current on the ammeter is 186 milliamps. Sometimes I find this useful to write this onto the circuit diagram myself. First things to consider with the question is asking you which statement about the current through the lamps is true, and you're given 4 options. Now, all the options you've been given all have units of amps, so you are going to have to be able to convert between milliamps and amps. So you're required to remember that there are 1000 milliamps in 1 amp. This means the current on this ammeter is 0.186 amps. Now, in order to decide the actual current going through each lamp, you have to consider the resistances. Now, these 2 lamps are identical, so therefore we can assume the resistance through them is the same. Also, you're required to remember how current behaves in a parallel circuit. In this case, the current will divide when it reaches this junction here. Because these bulbs are identical, the resistance is identical, the current going down each branch would be identical. So the current is essentially half of 0.186 amps. So the answer to 1.1 is the top answer, 0.0393 amps. 1.2 basically talks about, well, if one of the lamps breaks, so example, let's say that one breaks and is not replaced, what statement is true about the current on the other lamp? Well, essentially now the current only has one direction to go down rather than 2. So actually the current isn't the same, isn't 0.186 amps. It's exactly the same as it is for question 1.1. Because the current only has one route to go down, the total amount of current that can flow at any one time is half of the 0.186 amps, and so it is the top answer. Note on these questions that you're only asked to only ever tick one box. You could be penalised if you tick more than one box. Also, if you do change your mind, make it very, very clear that you have changed your mind to the examiner by putting a clear cross through one of the answers and ticking the other. Moving on to 1.3. So we're given a series circuit again, a variable resistor, a lamp and a cell. Now we're told the resistance of the variable resistor is increased. What effect will this have on the brightness of the lamp? And explain your answer. 2 marks. So there'll be 1 mark for basically saying what the effect will be, and there'll be a 2nd mark for saying why that is. Now, increasing the resistance in the circuit will decrease the current, and that will get you the 1st mark for remembering that fact. So increasing resistance decreases current. Therefore, what will happen to the light bulb? Well, the lamp will be dimmer. And that will get you 2 marks. 1.4 starts to introduce some maths to this question. 1.4 requires you to recall the equation that links current, potential difference and resistance. This is not on your equation sheet and you need to have learnt this equation. You could probably learn it in any form, and ideally it's best to write it in words, not in symbols. If you did it in symbols, you would have to define what each symbol means. So in this case, I'm going to write down potential difference is equal to current times by resistance. (1.5) now asks you to put some numbers to this that have been given to you above 1.4. We need to calculate the resistance of the lamp. So resistance, if we rearrange this equation, is equal to the potential difference, V, divided by the current, I. We put in the numbers and we can see the PD is 3.3 volts and the current is 0.15 amps. So 3.3 divided by 0.15, put that into your calculator, you'll get 22 ohms. Don't forget to put the answer down in the corner here if they give you one. There is no mark for getting the correct unit as the unit has already been given to you. The final part of this question, 1.6, again, is some recall. You need to sketch the current against potential difference graph for a filament light bulb. Now, this again is just pure recall. In order to get them 1 mark for this, you need to remember that the line starts from the origin, and in a light bulb, as the potential difference increases, the current increases, but the rate at which that current is increasing starts to decrease, so the gradient of our line will decrease. And it needs to look something like that.